Question 23. So this is quite a complicated question with quite a bit going on. There's some trigonometry in this one, there's some Pythagoras, and there's also going to be some volumes of pyramids. So the very first thing I need to do is I need to establish what the height of this pyramid is. So all I'm going to do for this one is I'm going to pretend that there is a point in the center of the squared base here, and I'm going to call that point O. So AO represents the height of the pyramid, and I can work that out by doing AB, which I don't know at the minute, squared, minus BO squared. So what I'm going to do for this is BD, which is the diagonal across the square base, can be given by BC squared plus CD squared. So BD is the square root of 200, which is 14.142, and then some bits after it. Now I don't want that whole diagonal. BD is 14 and a bit, so BO would be 7 and a bit, in this case 7.071, and I've kept quite a few of my decimal places afterwards just to ensure accuracy. So now I know what this one is, I should be able to work out the height. So if I go back to what I said earlier, AO squared equals AB squared minus BO squared. This gives me a height now of the pyramid of 7.071 centimeters. Once I've got this, I'm going to go back to my volume formula and I'm going to work out the area of the base, and I'm going to times it by the height. So the area is 10 times 10, and the height we've worked out is 7.071. That will give me the volume of the containing cuboid. Now if you remember from when we did volumes of pyramids, the volume of the pyramid or a cone or whatever it is always a third of the volume of the containing cuboid or cylinder. In this case it's a cuboid, so when I do a third of that, I get the volume to three significant figures of 236 centimeters cubed. In the second part of the question, I need to work out the size of the angle at the very top of the pyramid, the size of angle DAB, and I'm going to do this by starting to consider the triangle DAO. So if I just sketch this off to the side so we can all see it, there's D, there's A, and there's O. Now if this was a cross section of the triangle, I would see the rest of it coming down here and side B would be there, but I'm not too interested in that. What I can see though from this is that if I could work out this angle here, then the angle BAD, the one that I need to find, is actually just going to be double it. So what I'm going to do is I'm going to use some trigonometry, because this is a right angle triangle, to work out this missing angle in triangle DAO. So I know that this length here is 10 centimeters. I can see that from my diagram, and in the previous part of the question I worked out that this was 7.071 centimeters. Now all I'm going to do is I'm going to label my side, so I've got a hypotenuse and I've got an opposite. This tells me that it's a sine ratio, so I know that the sine of the angle, which we can call x, is equal to the opposite, 7.071, divided by the hypotenuse, which is 10. This gives me a value of the angle as approximately 45 degrees. Now once I know that that angle is 45 degrees, as I stated earlier, all I'm going to do is I'm just going to double it to get the angle DAB. So in this case my final answer here is 90 degrees.